Hi, recently I've been playing around with RS485 and I've made a little uh, board with an LCD that receives data over RS485, and in this video I'm gonna be talking about how to make something like this and generally how RS485 works in the realm of microcontrollers and stuff. So the system has two RS485 transceivers. The first one is connected to the computer, which is over USB, and it's basically MAX 485 on a breakout board connected to like a typical USB to UART transceiver. Uh, this board, it's basically constructed from two raster boards, and we're gonna talk about the construction of this thing in a moment. I also made this, which is 232 to 485 transceiver, and uh, this one and this one, they share the same design principle that we're gonna talk about in a moment. RS232 is quite nice, but sometimes you need to connect more than two devices together. So, the logical way would be to connect them like this, but you cannot really do this because so first of all, you need a crossover cable. So you need the TX from one device to connect to the RX on the other device, and the TX on the other device to connect on the RX on the first device. And that way, the data that appears on the transmission line from this PC goes directly to the receive line on this other computer. And the data that happens to be on the TX line, that means transmitted from this computer, ends up on the receive line on this computer. Now, if you wanted to connect an Arduino to this thing, this whole setup, then you either have to use a separate serial port on the PC, which sometimes you don't have, or you would have to connect it to a data transfer switch, which is basically a switch that you turn and it acts as if you've been changing the cables. You cannot connect them like this because if you happen to have those two TX lines connected together, then you're basically gonna get a collision, because if this computer pulls the TX line low to send some data, and then this thing will keep the TX line up, and you're basically gonna get a short circuit, because on one end the TX line is gonna be connected to negative voltage, and on the other end the TX line is gonna be connected to positive voltage, and magic smoke will emerge from somewhere. Now this is where 485 comes into play. So in a typical 485 bus, you've got those two common lines that are labeled A and B conventionally, and then you connect 485 transceivers to it. Now 232 is a full duplex bus, and that means you can transmit and receive at the same time. But 485 comes with a trade-off, and the trade-off is that it's a half duplex bus, which means that you can only transmit or receive at the same time. Now, when you want to send a byte or some data over 485, you first have to enable the transmitter, and in this case, this is by pulling the TXN line up. So we've got TXN. You first have to pull the TX enable line up. This enables a transmitter which forces some certain voltages on the 485 line. So you've got your TX from a computer, you've got A and B here. And you've got, those two lines here. So you pull up TX enable high to enable transmit, and then you start transmitting your data and stuff. And when you're done, you pull the TX enable low to disable the transmitter and free the bus. And then your TX driver will most likely emit something like this, which is basically the RS485 form of the signals you've just sent. And then the other transmitters, which are usually in receive mode, because receive mode basically means that the bus is free, they are gonna keep comparing those A and B lines, and they are gonna produce on the receive output, they're gonna produce the data that you sent to them. And this way you send bytes over 485. So when you're done transmitting, you pull the TX enable line low, and you start actually listening for the other device's data. What is also not drawn here is that you need bus terminators on both ends of the line, and that is to prevent reflections, which generally this mostly has effect on longer buses and higher speeds, but it's a good measure to add them anyways. So the way 485 works is pretty simple once you know the way how 232 works. Well, RS232 is the most popular RS serial transmission standard. It's present in most personal computers as this DB9 on the back, and basically a byte data sent over RS232 looks somewhat like this. You've got a stop bit, and you've got some data bits, and you've got a start bit, you've got some data bits, you've got a stop bit, and line goes back to idle mode. So that's 232 for yeah. And now 485 works practically the same, with the difference that you're transmitting a second line in parallel that is the inverse of the first line. So in our case, the second line would look somewhat like this. And this is called a differential transmission, and it has some advantages. Well, it mostly has advantages. That's because if you happen to have some sort of a electromagnetic interference across your lines, for example, from some powerful electric motor, and you've got some noise on the line, so let's actually draw something. A normal 232 would most likely get a frame error here, because this voltage would far exceed the space or mark voltage that would currently be there. But once you've got 485 and you've got two lines, then you've got the same noise profile on the second line, so it would look somewhat like this. And because the 485 receiver measures, actually it doesn't measure the voltage levels on each of the line, it actually measures the difference on the between the levels. So over here we've got a big difference, and that's gonna be a mark, and over here you've got small difference, and that's gonna be space. So if you have both lines and they're both offset by the same voltage, then the difference stays the same, and your 485 driver can actually decode this as a proper byte. So on the computer side, this is my 485 transceiver. The way this works is that using this USB to UART dongle, I'm generating UART signals, and the TX and RX from the UART go into TX and RX on this MAX 485. The plus 5 volts and ground go also over this cable to power this 485 chip. And I also mentioned that in 485 you need a separate GPIO to switch between the transmitter and receiver mode on this 485 transceiver. And as it happens, most of those USB to UART dongles have DTR broken out in a separate, on the same header as the rest, the main header. Well, they also have all the other UART signals broken out, but DTR is the easiest to use in my opinion. And basically DTR, which is the blue cable, goes from the USB to UART receiver and into the TX enable on the MAX 485, and you can toggle the state of DTR in software quite easily. So that's basically how you switch this in your program from receiving to transmitting, and vice versa. Now this AVR that receives data and displays it on this LCD display is also pretty simple in its construction. So on the bottom you've got the power supply section, which is just a 7805, and the interface, which is this MAX485 connected on this tiny breakout board, because I've got only, well, they only make MAX485 in SMD. And over the 6-pin cable, the data goes to the AVR on this board, and this board also houses the LCD stuff, which is basically the connector and a 10-turn potentiometer. So the way this works, the cable carries RX and TX from the AVR, and also carries, well, power, obviously. And this GPIO pin on this board, the GPIO pin that switches the 485 between transmission and receiving, is just one of the GPIOs on the microcontroller. You can also see 4 dip switches here, which are used to set the address. The AVR can read the address, and it indeed displays it on power up, but I haven't programmed yet what to do with the address. So as you can see, it reads the address fine. And if I change 2 of those switches, you should see that when I reset it, you should see that it reads a different address. It's not really doing anything yet with the addressing. I'm yet to implement addressing on my 485 thingy. But generally that's all you need on the AVR side to, well, receive and transmit 485. So the third device, which is actually the first 485 transceiver I made, takes normal RS232, which then goes through the MAX232 to be translated to 5V UART levels, and then this drives the 485 transceiver here, which is connected across those 2 DB9 and this terminal block connection, which, well, goes into another DB9, because those cables are pretty handy to use. And in this case, the same as in the USB UART based transceiver, DTR going low enables the TX. So now let's take a quick look at how 485 looks on the programming side. Now, on Linux and other Unix systems, serial I/O is done using Termios, nowadays at least. And Termios is basically a set of functions that control serial ports. As you can see, you can use the modem control IOCTLs to, well, set all the additional lines apart from RX and TX. You can set all those lines as if they were just GPIOs. That allows you to have a sort of rudimentary form of GPIO. As you can see, Termios is also in NetBSD, as NetBSD is another Unix operating system, and Termios is defined by POSIX, if I am not mistaken. So all of those functions control the serial port, and in case of those 2 IOCTLs, you can generally use those as a rudimentary form of GPIO. When it comes to programming the RS485, it's pretty much the same as programming normal serial transmission. If you've read my tutorial about Linux and AVR serial communications, you're gonna see that this is practically the same code. So over here you've got the UART print function, and this basically transmits an terminated string in this case over 485. And the only difference between this and the code in the tutorial is that you have a certain GPIO that you first enable to enable the transmitter inside MAX485. Then you transmit your message. That's a typical blocking UART implementations on AVR. Implementation on AVR, and then you just pull the GPIO down. On the computer side, it's again pretty much the same as the tutorial, with the difference that first we define an integer, which is the TOCM BTR. This is a flag that we then pass to an IOCTL, which is a TOCM BIC, which means to clear the given modem bits. And basically what this IOCTL does is it pulls DTR low, that enables our that enables our 485 transceiver, because the TX enabled on the 485 transceiver is wired to DTR. We then send our data, we TC drain, that means we wait until the data has been physically sent. We also then sleep for a moment because I had problems with TC drain and those USB UART dongles where TC drain would actually exit before it's physically sent, so the CO sleep is sort of a safety mechanism. And then we call another IOCTL, which is this TOCM BIS, which sets the modem bits in the flag. And this IOCTL basically pulls the DTR up. This pretty much is the demo, it's using the same code you've just seen. It's running on NetBSD on WinRAR 10 thin client that you've seen in my website. And well, porting this to NetBSD was just a case of recompiling the source file. You can see the little fish eating the thingy there, and then some blinking lights. So it's pretty simple to interface RS485, and it's pretty much fun. So that's all when it comes to RS485 between microcontrollers and computers. As usual, if you liked this episode, give it a thumbs up, and if you haven't yet, subscribe to my channel for more stuff like this. My name is Paul Brook, and I hope you've enjoyed this episode. See you next time.